Number 9, write the following numbers in scientific notation. Do not round. So let's take a look at the standard notation. Remember that when I'm writing in scientific notation, I want the decimal so that it's got one digit that is not a 0 before the decimal. So that means if I change this number to scientific notation, I'm going to be writing 7 before the decimal, and then 0.92. And then after that are a bunch of zeros. I don't write that. Anytime I have scientific notation, I'm taking this times 10 to a power. So let's take a look at how many times the decimal moved between where it started and where I want it to go. So the blue line right here shows where I want the decimal to go. Really, it's over here. So I'm moving it 3 spaces, 6 spaces, 9 spaces, 10, 11. So I moved it 11 spots to the left. That tells me that my magnitude is 11. So in scientific notation, this becomes 7.92 times 10 to the 11th power. Let's use the same strategy for the next problem. I know that I want one digit to the left of the decimal. So that means I would like 6.0438, and it says do not round, so I'm going to use all of those digits to write this. So when I write this in scientific notation, I'm starting with 6.0438 times 10 to some power. Let's take a look at what that power will be. I know that the decimal starts out at the end here, and I'm moving it 3, 6, 9, 10 spaces, and it's a really big number. So my power, my magnitude here will be positive 10. The next two problems, we're looking at a negative magnitude. And the reason we're looking at a negative magnitude is we're looking at really small numbers rather than really big numbers. So let's use the same strategy. We know we want one non-zero digit to the left of the decimal, which means this 9 over here, that's going to be our non-zero digit to the left of the decimal. And then we've got 7, 6 afterwards. So let's start by writing out our scientific notation. We're starting with 9.76 times 10 to a power, and we just need to figure out what that power is now. So we want the decimal between these two numbers, and the decimal is currently over here. So I'm going to count in threes. There's 3, 6, 9, 10 spots that I moved it. But this time it's a really small number. So that means I'm using a negative power of 10 rather than a positive power of 10. So this becomes 9.76 times 10 to the negative 10th power. Let's use the same strategy for the one below. I know I want one non-zero digit to the left of the decimal. My first non-zero digit is that 6. So when I write this out, I'm going to have 6.0859 times 10 to some power. And in fact, I already know it's going to be a negative power because it's a really small number. It is a decimal. It's less than 1. So let's count the spaces that I moved the decimal. The decimal starts here, and we're going 3, 6 spaces. So it should be 10 to the negative 6th power because that magnitude is always counting for us how many times we moved the decimal place, right? Because in base 10, which is the number system we use, this tells us how far over the decimal place goes. That's really what that number tells us. All right. For the last two, we have numbers that look like they might be written in scientific notation, except that we don't have only one digit to the left of the decimal, like in all our answers here. So there are two ways we can approach this. I'm going to show you the long way first, and then afterwards I'll show you my preferred easier way. So the long way. For 1,353 times 10 to the 7th power, what I'm doing is I'm imagining that I'm taking 1,353, and then the decimal point would be there, but I'm moving it over 7 spots, which in this case equates to putting 7 zeros at the end. So there's my number. So if it's easier for you, you can start with this number and then count backwards to figure out the scientific notation. So we'll use the same strategy. We know we want the decimal between the 1 and the 3, which means to get it from where it belongs to between the 1 and the 3, I'm moving it 3, 6, 9, 10 spots. So in scientific notation, this number would become, 1.3 times 10 to the 10th power. Here is what I consider an easier way to do this. Right now, we're starting with 1353 times 10 to the 7th. We know that we want the decimal so that it is between the 1 and the 3. So that means I have to move the decimal 1, 2, 3 places to the left, making this smaller by a factor of 10 to the 3rd power. So I made this number smaller. I turned it from 1,353 into 1.353. So I need to make this other number bigger, 10 to the 7th, to compensate for that. So I'm just balancing this out. So my first number became smaller. It went from a number bigger than 1,000 to 1.353. So I made it smaller by a factor of 10 to the 3rd power. So I have to compensate for that by making my magnitude bigger by 10 to the 3rd power. So it's going to be 10 to the 7 plus 3. So my final answer then becomes 1.353 times 7, 10 to the 10th, rather. Let's use this second strategy to describe our last problem here. So we're going to use the same idea of just making one smaller by a certain factor of 10 or power of 10 and making the other bigger by the matching power of 10. So 0.0014 times 10 to the 11th, in order to put that in scientific notation, I would want the decimal to be between the 1 and the 4. So to move it there, what I'm doing is I'm taking the decimal and I'm moving it 1, 2, 3 spots to the right. So I moved it 3 spots and I made it bigger, right? Because it started out as 0.0014 and 1.4 is bigger than 0.0014. So in order to compensate for that, I need to take this 11 and make it smaller by that same number of spots. So to make up for the fact that I made this bigger by a factor of 10 to the 3rd power, I'm going to make my other factor smaller by a power of 10 to the 3rd power. For my final answer, that gives me 1.4 times 10 to the 11 minus 3, which is 8, so times 10 to the 8th power.